Hello, everyone. Moving forward to question number 3, we have the function solve the equation ahead, which is in parentheses the square root of x plus y plus the square root of x minus y, close parentheses, minus parentheses again, the square root of x plus y minus the square root of x minus y, close parentheses, y prime is equal to 0 when x is greater than 0. Okay. So starting a little bit here with the problem, first things first is I want to separate the function and get the dy dx, which is the y prime, on one side and then the function onto the other side. So first I subtracted the parentheses of x plus y square root minus the square root of x minus y so that they would be positive on both sides. And then after that, the next step I did was to divide the parentheses of the square root of x plus y minus the square root of x minus y, so that my final function of dy over dx is equal to parentheses the square root of x plus y plus the square root of x minus y, close parentheses, divided by parentheses again, x, the parentheses square root of x plus y minus square root of x minus y. All right, and in doing so, looking at the step was very confusing. So one thing I want to do was get similar terms together. So I multiplied by the giant one of the parentheses square root x plus y plus the square root of x minus y, close parentheses, divided by that same function, get the giant one. The reason why is because I want to get a function that had more similar coefficients. Looking at this problem, it was very hard to get terms that are that were able to move from one another, because this is a non-homogeneous function and it's not linear. So in doing so, I finally came up with the equation dy divided by dx is equal to x plus the square root of x squared minus y squared over y. All right, and then after that, the next step was to multiply by y and divide by dx. So I have y times dy is equal to x dx plus the square root of x squared minus y squared dx. Okay, and looking for the next step, I tried to differentiate or move it so that it could all be on one side. So I have x dx, oh no, y dy minus x dx. No, I had it right the first time. I wanted to keep the x positive. I'm sorry. So I have x dx minus y dy plus x squared minus y squared to the 1/2 power, which is the same thing as the square root, dx is equal to 0. Okay. And then after that, I want to get the derivative of this function so that they're with respect to each other. So I have 1/2 of the derivative of both functions, the integral of both functions, is equal to x squared minus y squared plus the square root of x squared minus y squared dx is still equal to 0. Okay. And the next step after that was trying to get these functions to themselves. So in doing that, I did, let's see. I separated them. So I found that 2 of the square root of x squared plus y squared plus 2x is equal to 2y. And then getting rid of the 2's, I have y is equal to x plus the square root of x squared plus y squared. Sorry, didn't have that right there. Hand was in the way. And that right there is how do we solve for this non-homogeneous nonlinear function.